Good evening. This is Professor David J. De Los Reyes, an electrical engineer by profession. Okay, and an electronic troubleshooting on the so-called hands-on troubleshooting. Okay, let's proceed. Guys, my topic tonight will be parametric equations. So I will try to start. Okay. This was lesson number 94 on my channel, which involves mathematics, electronics, plus some other things under integral calculus, under the subtopic length of arcs. For tonight, it will be parametric equations. We are now through with the Cartesian. We are now through with the polar. So tonight, I will be presenting a problem involving parametric equations. Okay, I will try to read the problem. Find the length of arc. We are given the parametric equation x equal to theta minus sine of theta and y is equal to 1 minus cosine of theta with the range from theta equal to 0 to theta equal to 2 pi. The initial limit will be 0 degree and the final limit will be 2 pi or 360 degrees. We are given the parametric equation x equal to theta minus sine of theta, y equal to 1 minus cosine of theta. So it seems for the meantime we are given x as a function of theta and y as a g of theta, because they are different. Okay, so actually the parameter here is actually theta, because initially under the Cartesian it is x and y as a function of something else, but under parametric there should be a parameter here. The parameter is the third variable thing, it is theta. So the problem is asking the length of the arc represented by the parametric equation x equal to y function of theta and y g of theta, in which the actual value of x is actually theta minus sine of theta and y is equal to 1 minus cosine of theta. Okay, let's try to plot the graph of the parametric equations. The point plotting is somewhat like, it's very tedious. You just take your time, you assume an angle, solve for the values, then plot it by so-called point plotting. So it's just easy. It's just like on the, what they call these plane areas, when we were under polar coordinates. Okay, we assume a theta, then we will compute for the radius. And here, you assume a theta, you solve for x. And you assume a theta, and then solve for y. Then later on, try to plot that x and y corresponding to the given angle theta. So let's proceed. From the equation x equal to theta minus sine of theta, okay, I will just try to place some values here. This is x column, theta column, this is sine of theta column. On the second one, y is equal to 1 minus cosine of theta. So I will place it here, y, the value of theta, and cosine of theta. For the first one, this is theta. We will complete the one complete revolution. So theta initially is at 0, pi over 2, 90 degrees. Pi is 180 degrees. 1.55 is 270, and 2 pi is 360. We complete the one complete revolution. We will try to see the graph, okay, visually. The ranges are actually a little bit by 90 degrees, but at least we can see the view, okay? Also for y, 0, pi over 2, pi, 1.55, 2 pi. Okay, let's proceed. It is something like this. When theta is 0, sine of 0 will be 0, okay? So 0 minus 0, the value of x will be 0. So when theta is 0, sine of theta will be 0. So 0 minus 0 will be 0. Okay? Let's go to y. When theta is 0, cosine of theta will be 1. Cosine of 0 is 1. So this will become 1 minus 1. And the value of y will be 0. Okay? So corresponding to this x here to be 0 and y to be 0, plot it on the Cartesian coordinate system. It is this. Right? It is 0, 0. Then so on. When theta is pi over 2, sine of theta will be 1. Okay? Pi over 2 minus 1, it will be 0.57. Okay, that's the next abscissa. Same pi over 2. Cosine of cosine of 90 is 0. So 1 minus 0 will be 1. So corresponding to the angle pi over 2, the abscissa will be 0.57 and the value of the ordinate is y. 1 rather. Okay? So when x is 0.57, okay, y is 1. That is the point. Okay? And so on. We go to 180, 270, and 360. So at 180, this is the point. These are the abscissas. It got coordinates 3.14 and 2. At 270, it got coordinates 3.7 and 1. Okay? Then at 2 pi or 360, the value of x is 6.28 and y will be 0. It is 6.28 and 0. The fourth one is actually 3.7 and 1. And actually this one is 3.14 and 2. Okay? So at 90 degrees or at 0, the x and y is 0, 0. At 90 degrees, x and y is this one. At 180, the value of x is actually 3.14 and 2. At 270, the value of x and y is 3.7 and 1. And at 360 or 2 pi, it is 6.28 and 0. So if we try to connect the 5 points, the graph will be something like this. And this is the graph represented by the parametric equation x equal to theta minus sine of theta, y is equal to 1 minus cosine of theta. At least we now know the graph. So the problem is asking what will be the total length of the arc? Okay? What is S equal to? Right? So we are halfway through our solution. So if we try to bring back the differential equation for parametric equation, I think I've given you this one the last time around. Differential length of arc under parametric equation is dx over d theta quantity square dy over differential theta quantity square times differential theta. Okay. First one is dx differential theta, dy differential theta, square value. We are given x and y, so x will be theta minus sine of theta, dx over d theta will be 1. Differential theta, the differential of theta is just 1 with respect to itself. So this is 1 minus cosine of theta. Squaring dx over differential theta quantity square, the square of this, 1. 1 times this is minus cosine times 2. The third part is the square of this one. Negative, negative, this will be plus equation number 2. For y is equal to 1 minus cosine of theta. Take dy differential theta. Dy differential theta will be, this will be 0 minus open quantity. The differential of cosine is minus sine, so this is minus sine of theta. So this is minus minus, this will become plus. Meaning dy over differential theta is sine of theta. Squaring both sides, dy differential theta quantity square equal to the square of sine of theta is sine square of theta, equation number 3. Okay? So if we try to take the value of equation number 2 and 3, we'll put it in number 1, it will be this. First part is 1 minus twice cosine of theta, cosine square. dy differential theta, quantity square is sine square of theta. All quantity times differential theta. Okay, this is times differential theta. Okay. Cosine square plus sine square will be 1, so that's 1. We got the 1 here. Minus twice cosine of theta. Factoring out the 1 inside, 1 plus 1 is 2. We factor out 2 times the quantity 1 minus cosine of theta under the radical sign times differential theta. The operation inside is multiplication. We could take the square root separately. So differential length of arc will be the square root of 2 times the square root of 1 minus cosine of theta times differential theta, equation number 4. And this is not yet integrable. So by using trigonometric identities, sine square theta, cosine square equal to 1, 1 minus cosine square is equal to sine square of theta, it's just algebraic manipulation, guys. 1 minus cosine square is actually a perfect square, right? Oh, no, a product of two things, 1 plus cosine and 1 minus cosine. Because if we try to multiply this one, the middle term will vanish. What will only come out will be the first term and the square term. So actually 1 minus cosine square is the product of 1 cosine theta times the quantity 1 minus cosine of theta equal to sine square of theta. Then computing for 1 minus cosine, we put this one underneath. Therefore 1 minus cosine will be sine square over 1 plus cosine of theta. Then taking the square root of both sides, the square root of 1 minus cosine of theta will be the square root of cosine 1 minus cosine of theta equal to this. On the right hand side, the operation is division. So actually we could take the square root separately. So the square root of sine square will be sine of theta, and the square root of the bottom portion will be the square root of 1 plus cosine of 2 theta. So meaning, we will take this value here, then place it here. Okay? So differential length of arc will be square root of 2 times the equivalent of 1 minus cosine of theta, which is this. Okay? So it will be sine theta all over the square root times differential theta. Then we try to bring out the 1 underneath. So this should be square root of 2. This will be negative 1 half sine of theta differential theta. And I think this now falls under the integral of u to the n. And that will be u raised to n plus 1 over n plus 1. Right? Where the value of n is negative 1 half. But we must have to verify the value of du. Du is the one inside. It is 1 plus cosine. Du will be 0. The differential of cosine is minus sine of theta, differential theta. It is not exact. So actually this one is almost equivalent. Is almost equal to this one. Right? Except for the negative sign. So differential length of arc will be square root of 2. We place negative 1 outside to counter the negative inside. Okay. 1 plus cosine negative 1 half. We place the negative sign over here, right? So it now falls under the power formula. So this will be square root of 2 times negative 1 will be negative square root of 2 times the quantity. This is power formula, so it should be 1 plus cosine minus 1 half plus 1 is 1 half all over 1 half. So actually, this is over 1 half, or actually we could remove this one, then place 2 here, negative. Okay? With the limit, the problem is asking from 0 to 2 pi. I will not show you anymore the simplification. It is just a matter of simplification and substitution. If you try to compute for S, the total length is 8 units. Okay? You can use your calculator. Okay? Place the upper limit minus the value of the lower limit. What will come out will be 8 units. So meaning, the total length of the arc represented by the parametric equations from this to here is actually equal to 8 units. That's it, guys. An example of length of arc computation under parametric equation. So it is a must that you should visualize first your graph so you could see it where it will be coming out. What will be the view? And from our tables over here, using the 5 pointing, 1, 2, 3, 4, 5, 0, 90, okay, 180, 270, and 360. That's the graph. And the total length, as per our computation, the length is 8 units. Good evening, Los Angeles.